we have one final video for the whole week. Hopefully you're not doing this on Wednesday night, in which case you'll have new videos tomorrow. Maybe if you do this early, you get a little bit of a break. Anyway, here we go. So we're going to use metric conversions to solve problems. We're going to start with example 5.14, which is a little silly, but it is what it is. We got one boxer weighing in at 85 kilograms. A kilogram is about 2.2 pounds. So this is like, what? Close to 200 pounds? I don't know. And he is 80 dag. Now you're looking at this, you're saying, Jason, what the heck is a dag? Remember, weight in the metric system is grams. So DA is the prefix. If you don't remember what DA means, is the prefix, go back to your table and look for DA. DA meter is a decameter. So DAG is a decagram. A decagram is going to be 10 grams. Okay, so one boxer is 85 kilograms. Oh, I'm trying to show you the table. I'm on the wrong scene. It's right here. So one boxer is 85 kilograms and he's 80 decagrams heavier than his opponent. And the question is, how much does his opponent weigh? Okay. So let's, any application problem, any word problem, write down your information. Okay. So we have a boxer that's 85 kilograms. Let's call this, you can name the boxer. Let's name this boxer Jason. Jason's 85 kilograms. So Jason is 80 decagrams heavier, so more than the other boxer. Let's call the other boxer Brian. All right. In reality, I'm probably way more than 80 decagrams heavier than Brian, but let's for the problem. Here we go. So, and the question is, how much does his opponent weigh? So how heavy is Brian? So let's get everything in kilograms. When people talk about weight, they're either saying pounds or kilograms. Nobody's talking about decagrams. Why is this problem talking about decagrams? Okay, so let's get everything in kilograms. So what the heck is 80 decagrams? Question mark. Let's start with there. So we're going to go back to our table and say, what the heck is a decagram? A decameter is 10 meters. A decagram is 10 grams. Okay, so let's start with that. So a decagram, 1 decagram is 10 grams. And remember that 1,000 grams is 1 kilogram. So let's, whoa, 1,000 grams is a kilometer? Nope, is a kilogram. So let's figure out what this is. We have 80 decagrams. And we know that 1 decagram is 10 grams. And we know that, so decagrams are canceling. And then 1,000 grams is 1 kilogram. So now we only have kilograms, everything else cancels. So multiply this across. And we're going to get 80 times 10 is 800. 800 divided by 1,000 is 0.8. Use a calculator for this. You don't have to do it in your head. 0.8 kilograms. So that's not our answer, right? Jason is 80 decagrams. So Jason is 0.8 kilograms. So if you want to update it, right, this is 0.8 kilograms more than Brian. So Brian is 0.8 decagrams. Sorry, Brian is now, if I'm 0.8 kilograms more than Brian, Brian is 0.8 kilograms less than me. So 0.8 kilograms less than 85. So Brian is 0.8 kilograms less than Jason. who is 85 kilograms. So what's 0.8 kilograms less than that? 85 kilograms minus 0.8 kilograms is going to be 84.2 kilograms, which if we're boxing, we do want to be in the same weight class. Hopefully I did my math right. And that's going to be our answer. That's how heavy Brian is. Also very close to 200 pounds. All right, that's the first application. Again, for all of these, let me know if you have questions. So we got our next problem. Example 515. A 2-liter bottle contains 87 centiliters of oil and 4.1 deciliters of water. How much more liquid is needed to fill the bottle? So a picture might help too. All right, so we've got a 2-liter bottle. I don't know what kind of bottle this is. So the whole thing, right, is 2 liters. Wait, do we use lowercase? Wait, I'm actually completely forgetting for liters, whether it's lowercase or uppercase. I think it's uppercase, isn't it? All right. So we got a bottle and it's a 2-liter bottle. And inside this bottle is 87 centiliters and 4.1 deciliters. So it's got 87 centiliters of oil. So it's got some oil. It doesn't have to be drawn to scale. So let's say it's got 87 centiliters. Remember, centiliters is little c. And 4.1 deciliters of water. Remember, oil and water aren't mixing, so 4.1 deciliters, little d, liter. All right. And the question is, what's this left over? I know people don't like letters, but you could call this X if you wanted. I'm going to write a question mark. So got some of this, some of this. How much is left over? And just like before, we're talking apples, oranges, and bananas right now. We need to get everything in the same units. So we need to figure out how much is 87 centiliters? How much is 4.1 deciliters? We need to find that out. All right, and this is, the first one is oil. Second one is water. Let's figure out how many liters this is. So that's how we're going to start. With 4.1 deciliters, we want to know how many liters that is. So we look at our conversion table. So what's the relationship between deciliter and a liter? So 10 deciliters is 1 liter. So 10 deciliters is 1 big liter. So we multiply and do the conversions, just like we've been doing all week. Deciliters cancel. 4.1 divided by 10, do that on a calculator. You're going to get 0.41 liters. That's how much oil we have. So don't necessarily box it because it's not our answer, but I don't know, maybe you could cover it in some kind of shape. We can bush it. I don't know. Write that down for later. We can have, oh, here's a better idea. All right, let's take our nice, whatever kind of jug this. Actually, this looks like something. It doesn't matter what this looks like. Okay, so the oil is 0.41 liters. So now let's figure out how much the water is in liters. Wait, this is the water. This is why I don't draw. This is why you don't use pen. Ooh, welcome to week 1, everyone. Actually, I guess this is your week 2 assignment. All right, so we got 0.41 of the first one. The question is, how much is 87 centiliters? We also want to convert that to liters. So you go back to your table and find out that 100 centiliters is 1 liter, and we convert that. 100 centiliters is 1 liter. The centiliters cancel. And we're going to get 0.87 liters for the second one. And again, we'll bush it. So we have 0.41 liters of water. We got 0.87 liters of oil, 2 liters total. So how much is left over? So we have 2 liters total minus 0.41 of water minus 0.87 of oil. Subtract that on a calculator. 2 minus 0.41 minus that. Let's do it together. 2 minus 0.41 minus 0.87 is 0.72. So 0.72 liters is our answer, which is 72 centiliters, 7.2 deciliters. How many megaliters is it? I don't know. Not very many. Megaliters are big things. All right, and that's that problem. All right, so next we're gonna finish off by doing a little bit about temperature. So temperature is going to require that we use some formulas. All right, so if you hate algebra, we're getting back into some algebra. Okay, so Fahrenheit and Celsius. Fahrenheit, again, is imperial units. It's what we use in the US, but it doesn't make a lot of sense. Whereas Celsius, there's a lot of explanations for why Celsius is nice. 0 Celsius is freezing, 100 Celsius is boiling, and 1 degree Celsius means something about heating water or something. Wait, no, I'm thinking of calories, I think. Disregard. So these are the formulas. If you want to convert Celsius to Fahrenheit, you got that formula. You want to go the other way? That's the other way. They're inverse functions of each other, but we're not talking about inverse functions in this class, so I'll hold it inside. So can we use the formula? That's what these 3 examples are. Mr. Super Travel, what a nice name. Anyway, don't get excited. Mr. Super Travel is not coming in until example 518. So Super Travel is going to be waiting a little bit. Let's do example 516. All right, the boiling point of water is 100 degrees Celsius. 100 degrees Celsius, written like this. And the question is, what temperature does water boil at in the Fahrenheit scale? So we want this to Fahrenheit, degrees Fahrenheit. So before, we would say 1 kilogram is equal to 1,000 grams, and we'd multiply with a fraction. But here, we're just going to use the formula. So we have Celsius, and we want Fahrenheit. So if we want Fahrenheit, this is what we want. We're going to use the formula that has the F by itself. This is our output. It's the thing all by itself. This is what we want. Fahrenheit is 1.8 C plus 32, and C is 100. So it's going to be 1.8. Plug this into the formula. We're going to have too many arrows here. Forgive me. 1.8 times 100 degrees plus 32. Type that into a calculator. So go over to Desmos or whatever calculator you want. We have 1.8 times 100 plus 32 is 212. So 100 degrees Celsius is 212 degrees Fahrenheit. And that's all there is to it. Find out which formula you have to use, plug in the number, use a calculator. Let's do 517. Water freezes at 32 degrees Fahrenheit. What is this in Celsius? So we have 32 degrees Fahrenheit. I already spoiled this one for you guys, so forgive me. You should already know the answer if you were paying attention. Let's get this taken care of. Okay, so this is what we want. The thing that we want needs to be alone. We don't want to have to solve for anything. We don't want to move terms around. So the C is the formula we're going to use here, because that's what we want. So the C formula is C is equal to F minus 32 all over 9/5, aka 1.8. And then we just plug in the F. So we get 32 minus 32. Whoa, divided by 1.8. You can use a calculator if you'd like. Or 32 minus 32 is 0. Zeros might make you a little nervous in a fraction, but it's only dividing by 0 that's a problem. You can use your calculator to verify this is going to be 0 degrees Celsius. The freezing point for Celsius is 0. Very easy number to memorize. Remember. All right. Last one. You've been waiting for it. Mr. Super Travel is coming around town. Example 518 has Mr. Super Travel in it. What a name. I'm going to name my kid Mr. Super Travel. I don't have a kid. Maybe it's a good thing. Okay. Mr. Super Travel is researching vacation destinations, and he sees that the average summer temperature in Barcelona is about 26 degrees Celsius. What is the average temperature in Fahrenheit? Okay, let's look at it. The average temperature is 26 degrees Celsius, and we want to know what is that in degrees Fahrenheit. So again, this is what we want. The thing that we want needs to be by itself. So we use that formula from earlier, 1.8C plus 32. Just plug in what the C is. 1.8 times 26 plus 32. Use our calculator. And we're going to get 1.8 times 26. That's not the times. Plus 32 is 78.8 degrees. That is too hot for me. I guess it depends on what you're doing, though. If you're going to the beach, honestly, if you're going to the beach, 80 degrees is a little cold because it's a lot of times windy at the beach, right? I guess it depends. That's West Coast beaches. Anyway, I've never been to a beach in Spain. If you've been to a beach in Spain, you should let me know in the weekly check-in how your Spanish beach was. Anyway, this is the average temperature in Barcelona. So this is the answer to our question, making sure to answer with correct units, make sure we're answering the correct question, make sure that our drawings aren't terrible, and that's it for this week. So should have everything you need to go do the homework now. Best of luck, and please check your answers and ask me if you're struggling with anything. Bye-bye and good luck.